What if I told you that life might be floating in the clouds of Neptune right now, surviving in one of the most hostile environments imaginable? While scientists search for life on Mars and the icy moons of Jupiter and Saturn, a radical new theory suggests that Neptune's atmosphere could harbor microbial organisms drifting through layers of methane, hydrogen, and helium nearly 3 billion miles from the Sun. This isn't science fiction. This is cutting-edge astrobiology, and the implications are staggering. Neptune has always been considered a frozen graveyard, a world so distant and inhospitable that the very concept of life there seems absurd. But recent discoveries have forced us to completely rethink what we know about life in extreme environments. Here on Earth, we found organisms thriving in boiling acid pools, frozen Antarctic ice, deep ocean trenches with crushing pressure, and even floating in our own atmosphere at altitudes where the conditions mirror those found on other worlds. If life can adapt to such extremes on Earth, why couldn't it exist in the clouds of Neptune? Let's start with the basics. Neptune is an ice giant, the eighth and farthest planet from our Sun. Its atmosphere is composed primarily of hydrogen and helium, with significant amounts of methane that give the planet its striking blue color. Temperatures at the cloud tops plummet to minus 214 degrees Celsius, cold enough to freeze carbon dioxide solid. Wind speeds exceed 2,000 kilometers per hour, making Neptune's storms the most violent in the entire solar system. The pressure increases dramatically as you descend through the atmosphere, eventually reaching levels that would crush any spacecraft we've ever built. On the surface, Neptune seems like the last place you'd expect to find life. But here's where it gets interesting. Between the frozen cloud tops and the crushing depths below, there exists a habitable zone within Neptune's atmosphere. Scientists call this the Goldilocks layer, where temperatures range from 0 to 50 degrees Celsius, remarkably similar to conditions on Earth. At this altitude, approximately 50 to 80 kilometers below the visible cloud deck, the atmospheric pressure is also comparable to what we experience at sea level. Water exists in liquid form here, suspended as tiny droplets in the dense atmosphere. This narrow band of relatively moderate conditions could theoretically support microbial life. The concept isn't entirely new. In 1976, the legendary astronomer Carl Sagan and physicist Edwin Salpeter published a groundbreaking paper proposing that life could exist in the atmosphere of Jupiter. They imagined vast floating organisms, some as large as cities, drifting through the Jovian clouds and harvesting energy from chemical reactions and sunlight. While their giant floaters remain speculative, the core idea that atmospheric life could exist on gas giants has gained serious scientific credibility over the decades. Neptune, with its similar atmospheric composition and structure, presents many of the same opportunities for life. The answer lies in Earth's own atmosphere. But how would life survive on Neptune without a solid surface to call home? Scientists have discovered entire ecosystems of microorganisms living in our clouds, floating at altitudes of 10 kilometers or more. These aerial microbes don't need soil or rock. They spend their entire life cycle suspended in water droplets, feeding on organic compounds and nutrients carried aloft by winds. They reproduce, metabolize, and adapt to the harsh conditions of the upper atmosphere, including intense ultraviolet radiation, freezing temperatures, and low pressure. If life has mastered the art of atmospheric living on Earth, there's no fundamental reason it couldn't do the same on Neptune. The key to survival would be buoyancy. Any organism in Neptune's atmosphere would need to maintain its position within the habitable zone, avoiding both the frozen upper clouds and the scorching depths below. On Earth, atmospheric microbes achieve this by regulating their size and density, sometimes forming aggregates that can control their altitude. On Neptune, hypothetical organisms might use gas-filled bladders or structures similar to the swim bladders in fish, adjusting their buoyancy to stay within the optimal temperature and pressure range. Some scientists have even proposed that Neptunian life could produce hydrogen gas through metabolic processes, using it to stay aloft in the heavier atmosphere. Energy is another critical factor. Life needs fuel, and Neptune receives only a fraction of the sunlight that reaches Earth. At its distance from the Sun, Neptune gets about 900 times less solar energy than we do. Photosynthesis, as we know it, would be nearly impossible. However, Neptune radiates more than twice the heat it receives from the Sun, meaning the planet has a powerful internal energy source. This heat rises from the core through the atmosphere, creating temperature gradients and chemical reactions that could sustain life. Hypothetical Neptunian organisms might feed on organic compounds formed by ultraviolet radiation and lightning strikes, or they could harness chemical energy from reactions involving methane, ammonia, and hydrogen sulfide, much like certain extremophiles on Earth.